Howdy AP statistics students. We're going to go through testing for a significant difference between two population means. And so I apologize, this video is a little late getting uploaded. There was a faculty meeting this morning, and then I had a little technical problems, but we're gonna get you there today. So let me just get started so this video can go up pretty quickly here. So I have a scenario here, and we're going to take a look at it. And in a study of heart surgery, they're testing something called beta blockers on the pulse rate of the patients during surgery. And we have our subjects that are divided at random into two groups of 30 patients each, and one group gets the beta blocker, the other is a placebo. And we're going to check to see if there's a statistically significant difference between the two groups' pulse rates during the surgery. And so I'm going to start by saying I'm going to check my conditions. And what I'd like to do is show that they are, this is random. Well, that, as usual, was given in the problem. Normal. Well, obviously, our sample sizes are both greater than or equal to 30. So the central limit theorem is going to take care of the normal condition for us for the distribution of sample means. And independent, in this case, the randomization into the two groups achieves independence. So the two groups are as much alike as possible. So I'm just going to write random assignment here. All right, so what are we testing? Well, we're going to have, for mu1 is the mean, pulse rate of the treatment group. And mu2 is the mean pulse rate for the placebo group. And so our null hypothesis is, of course, that mu1 minus mu2 is in fact 0. In other words, there is no difference between the two. My alternate hypothesis, well, if I look at the data carefully, I see that the treatment group had a mean pulse rate of 65.2, and the control group had a mean pulse rate of 70.3. So for this case, because I'm trying to prove that maybe the beta blockers helped maintain a lower pulse rate, a healthier pulse rate, I'm actually going to say that mu1 is less than mu2. So mu1 minus mu2 is in fact less than 0. And so that's the those are the hypothesis designations. Of course, you could go with the alternate form. The null is that mu1 equals mu2. The alternate would be that mu1 is less than mu2. I kind of like the subtraction ones better because when we get our t statistic later, it's going to make a little more sense to have the subtraction, because then it's like when you look at the t distribution, the mean is 0 and so on. I need to decide on an alpha, and so I'm going to set my alpha to be 5%. A lot of times that's not a choice you get, but in this particular case, we did get that, so there we go. My sample statistic, I'm going to have x1 bar minus x2 bar. And so for this one, I have 65.2 minus 70.3. I'm just doing that on my calculator here to show that I have a, there it is, a negative 5.1 difference of sample means. And what I need to figure out is what does sigma for mu1 minus mu2 look like. And as you know, that should be sigma 1 over the square root of n1. squared plus sigma 2 over the square root of n2 squared. But we don't know sigma 1 and sigma 2 in this case. All we have are the sample standard deviations, which is why we're doing t-distribution, even though we know these are approximately normally distributed. So this is approximately equal to S1 over square root of n1 squared S2 over square root of n2. Because remember, I have to add variances. I can't just add standard deviations. And so I'm going to take my two sample standard deviations that are given up there, and you can see there's 7.8 and 8.3. So 7.8 over 30 and 8.3, oops, 30. And this gives me the square root. Oh, sorry, yeah, this was all supposed to be in a square root. Sorry. Because remember that I'm adding variances, so this is the square root of 4.324. So that's my standard deviation. I'm going to find my t statistic now. T in this case is negative 5.1 minus 0, because that's the default assumption there, over the square root of 4.32. Let's put that in here. This is 2.0795. And I got a t statistic of negative 2.45. Now, as you know, 543. When you go to table B, if you're a table B kind of person, you won't find 2.453. So more than likely what you'll have to do is go between two. If you're using your calculator, which I am here, oops, I'm on the wrong menu, there we go. You could just go in and do the inverse t distribution. Not inverse t distribution. What am I doing? I said inverse t distribution and didn't mean to, and then I went to inverse t distribution. We just need the t distribution. TCDF. Lower bound would be negative infinity. Upper bound would be negative 2.453. Degrees of freedom, of course, in this case is 29. And there we go. And so my p-value is the probability of t less than or equal to negative 2.453, and that is 0.01. So you can see the p-value is actually less than alpha. Therefore, we're going to reject our null hypothesis. And then at the end, of course, the last step, step 6 in all of our flowcharts that we've had is always to restate that in context. So in the case of the particular test, experiment that we're looking at, we would say something like at a 5% level of significance, our data does show a statistically significant reduction in mean pulse rate for the group that took beta blockers as opposed to the group that did not take beta blockers. Something like that. The wording's not, too particular here. Just make sure that you bring in the context of mean pulse rates during surgery, and that the group, the control group, was significantly higher than the experiment group, or the experiment group was significantly lower. The group that took beta blockers did seem to have a reduction in the mean pulse rate during surgery. And restate that with your level of significance alpha in there. So that's it. The notes that you have in your Google Drive kind of run through the same thing. I just want to make sure that you guys had an example to go from, and that's it. So hopefully that helps for the next part of the 10-2 assignment. And I'll see you guys tomorrow morning at 10:30 where we can get a chance to kind of meet for the first time in face-to-face-ish Zoom in a while, because I know it's been a couple weeks. So, all right, I hope you guys have a great afternoon. Looks beautiful outside, so maybe get outside and go enjoy some of this nice weather. All right, see you guys tomorrow.